record, and yeah, let's begin. Let me share my screen, and here we go. Hey everybody, this is Alex Merced, Senior Tech Evangelist at Dremio, and today we're going to be having a fun presentation about a really interesting topic, the semantic layer. We've all heard the semantic layer, we've heard discussions of the semantic layer, different people creating products around the semantic layer, and oftentimes sort of like what that is can be a little crazy. So we're going to have a presentation on that. But before we do that, I have a couple announcements. And of course, I want to give you the opportunity to download the slides. So the QR code that you see on the screen right now will take you to a shared Google Drive folder with the slides for this presentation. And also the slides from many presentations that I give. So basically, and most of them you can find probably on YouTube if you want to see any of the presentations whose slides you see in that folder. I do present. I do like to talk a lot. I am very interested in Data Lakehouse, Apache Iceberg, Dremio, all that stuff. So if you enjoy this presentation, do go check those out. But again, today we're talking about what is a semantic layer. And again, my name is Alex Merced. I'm a senior tech evangelist at Dremio. I've worked in the web and data spaces as a developer, and with companies like GenEd Systems, Crossfield Digital, Campus Guard, General Assembly. I'm one of the co-authors of Apache Iceberg, the definitive guide. And if you wanted to download a free copy of this new O'Reilly book, just came out a couple weeks ago, there's a QR code for that, and that will also be in the PDF of the slides in case you don't have a chance to scan this QR code now. But that'll get you a free complimentary copy of the book. I'm also the host of several podcasts. Again, I love talking about data, so I look for every excuse to talk about data, as you can tell. And these are the podcasts. There's 5 of them now, and you can subscribe to them on iTunes and Spotify. You can find links to everything at that URL at the bottom, bio.alexmerced.com/data. Links to all the social media, links to the podcasts, all that there. One place, make it real easy to find everything. And one more announcement. We are actually going to be doing an Apache Iceberg crash course at Dremio. So these are going to be 10 live sessions going over different topics regarding Apache Iceberg and going into sort of hands-on exercises, conceptual pieces, best practices, all these kinds of things. And the first one's going to be July 11th, where I'll be going over sort of like the basics of what Apache Iceberg is. And we'll be going all the way to getting hands-on with like Apache Spark, with Dremio, when it comes to like ingesting data with up into Apache Iceberg tables. This QR code will take you to where you can register for that. And with no further ado, let's get into our featured presentation. So to kind of understand sort of like why we want a semantic layer, we kind of have to take a look at how traditionally like our data evolves. And oftentimes we start off with like, operational data. Okay, and generally when we're talking about like our application systems that fuel sort of more transactional type transactions, our OLTP systems, we very much normalize the data. Okay, so essentially instead of having a sale record that has the information about the customer and their address, with the details of the order and their total for the order and the products that they bought, we break it up into lots of different tables to minimize duplication, to minimize the amount of storage space that we use, and overall sort of improve sort of the way we do transactional type records. Okay, and that's great in the transactional space because oftentimes I'm just grabbing one record here, one record there, and piecing together some information, and that works. But when we get into our analytical systems, we start wanting to sort of denormalize. We don't want all that. I want one record that has me all the information. Why? Because when I'm joining lots of records, joining all those records at the same time, especially as you start getting to larger and larger data sets, can get really, really time consuming and really increase the latency. So all of that might get denormalized into, let's say, a sales table, okay, where basically one sale has the information for that customer, that has the information for the products, the information for, and again, it might still get spread out into like maybe like a star schema where, some of that stuff is still out and joined, but we're essentially going to collapse it into such a more simpler model where more of the data is in one table. So in that bronze layer, we still just have the raw data. Okay, so oftentimes we have like this 3-layer cake of data where basically we have, you've heard bronze, silver, gold. We've heard, raw, other terms are like raw, staging. And then you have that gold layer is oftentimes also referred to as like the semantic layer. So that's kind of what we're building up to. But I have this raw layer where basically I just have the raw data, but I haven't cleaned it up yet. I haven't like deduped the data. I haven't checked for nulls. I haven't done any sort of that transformation that I might need to clean it and prepare it. So then I take that data and I'm going to go bring it into the next layer. So we'll say this is the silver layer, and I'm going to start, doing my deduping, doing my null checks, doing my interpolation, creating sort of a clean set of the data that my analysts need. But oftentimes, like they're not looking at sales; they're asking very specific questions. They're looking for very specific metrics, and that's where we sort of get into that next layer, the gold layer or the semantic layer. Okay, and the idea here is we're defining different metrics and measures. So basically, things that we speak about at a business level, sort of like they represent sort of like the business logic of the. So I might be thinking, oh look, I care about sales in July. Okay, so then we create a view or we create a materialization from that sales table that is just the records of sales in July 2024. Or maybe we're in a department that is trying to understand customer behavior. So we want to see stuff like maybe sales, average sales by customer, or a breakdown of sales by customer, or sales by region. If I'm managing a sales department and I'm trying to see, hey, which regions are performing best in sales, or if I'm trying to assess particular agents, or if I'm the product department trying to see, hey, which products are performing better. We start breaking this out into other sort of views of the data that represent more sort of our business logic and even more granular metrics and measures. Okay, so again, the idea here is we take that clean data and then we turn it into things that represent sort of more logically what our consumers are thinking of and the questions they're trying to answer. Okay, so that's all fine and good. The problem is data has been sort of crossed in a lot of different places. So what happens is that there isn't like a central place in the past for this semantic layer. You might model your data this way in different systems and different tools that you use, but they are always relative to the data you have sort of in that place. And then what you would do is you'd have to move that data from maybe you would coalesce all that data into a data warehouse or whatnot. So either you would have multiple models, or you would end up having to do all this data movement to get all the data in one place, but you still end up with multiple data copies. Overall, it wasn't the cleanest thing. Okay, so you're starting to get into this world where now basically, hey, what if you could do that kind of semantic modeling, but not just off data in one place, not just do that modeling in your data warehouse, but what if I could do it across my data in like different places? Like I have data in my data lake, data in this database, data in some of these files over here. How can I do that? And this is where you start getting into like semantic layer as a service, or trying to create these semantic layers. And there's been different approaches. So essentially, one tool was to create like a semantic layer cache at the BI tool layer. So you go to Tableau, you go to Power BI, many other BI tools. There's oftentimes some sort of semantic layer tool where you can define these metrics, define these specific sort of narrow metrics and measures, and you define them using SQL within that BI tool, and then that gets cached within the BI tool. The problem is, that those first two layers, bronze and silver layer, or that raw and staging layer, however you want to call it, is external to the BI tool. So then what happens is you might have different teams within the same company who use different BI tools. So one team in the company might be using Tableau, another team might be using Power BI. So that cache that's in one tool is not usable by somebody else. So you end up in this situation where you're caching the same metrics and measures over and over again and redefining them, which means their definitions might not be consistent across different people's BI layers. So again, you get duplicative and possibly inconsistent business logic across different teams. So ideally, we'd only define the semantic layer once. Okay, so that way, and then all my tools could feed off, whether I'm using Tableau or Power BI, it doesn't matter which team it is, I could feed off that sort of central layer. Okay, so that's where you get this sort of, now we're moving towards more of a decoupling. So you see like tools like Dremio provides a semantic layer, Cube as a tool that provides a semantic layer at scale. There's all these companies that provide like this sort of semantic layer as a service, where it's decoupled from the BI tool, and it's decoupled depending on the tool, decoupled from your data sources. So in this case, I can have, like with Dremio, I can have many different data sources and many different BI tools, but the semantic layer only gets defined once. I can define those metrics and measures, create that cache, and now it doesn't matter which team you're on and which tool you're using, you're all using the same consistent definition of that metric or measure. And that makes life a lot simpler because now we're all using the same version of, sales by customer. There's not we don't have 5 different versions of sales by customer depending on whose cache you're using, and that's going to lead to more consistent insights across teams. But Dremio goes a little bit further because Dremio is not just a semantic layer solution. Basically, the semantic layer is there as part of an overall platform for data lakehouses. Okay, so basically with Dremio, you can connect the different sources. So I can then create that semantic layer, and I can actually virtually do that 3-layer cake and create virtual views or tables on my raw, my staging layer, my semantic layer. But I can do them across different sources. So I could be joining Iceberg tables with Delta Lake tables, or Parquet data sets, or Postgres tables. All of these different data sources can connect directly to Dremio, and then I can model all that data on top of it. But typically, Dremio tries to facilitate a no-copy architecture. So instead of you having to create a physical copy of the data each layer, so where basically, hey, I'm going to take the join of these 2 data sets across these 2 data sources, and then create another physical table, and then create another physical table of each of my metrics. Beyond that, because again, that just increases the amount of storage, increases the amount of time that it takes to kind of write each layer. Dremio makes it really easy to do everything through logical views, and is super performant. So it actually makes doing things in a logical way pretty performant. Like without having to do any additional acceleration, you can usually get pretty good performance right out of the gate, even across all these different sources. But again, Dremio, you would do all that modeling. And then again, Power BI, Tableau connects to Dremio, they'll see the same sort of measures. And then Dremio also comes with like a wiki, so that way you can put things like common glossary of terms, create documentation around the different things you have, within any of these layers. So that way, again, people are using a consistent version, but they also have the context to understand sort of what data sets are available to them. But, and even if we go even further, like just to show you sort of an example, if I were building like a building modeling in Dremio, usually the color coding you'll see within the Dremio product is you'll see purple and green data sets. Okay, and just to see what that means is that whenever you see a purple data set, that means a physical data set. So like that's an actual raw table that's physically stored either in a database, stored in a data lake, or a data warehouse. Because Dremio can connect to all 3. It can connect to your Snowflake, it can connect to your Postgres, it can connect to your AWS S3. But let's say I create a join on this. What I can do is I can just write that SQL for the join, but save it as a view. So I'm not actually creating another physical data set, just like a view in a database. And then I can model those layers. So I can create my different views that derive all the way to the different metrics that I want to use. And at this point, I've created no physical copy. Okay, and if let's say I do need some acceleration here, instead of me making physical copies all along the way, Dremio has a feature called reflections. Okay, so this lightning bolt represents what's called a reflection. It's kind of like a mix of a materialized view and a cube. So just to make sure we're on just a level set, oftentimes we would use materialized views to accelerate raw queries. So we may have like a view in the data, but again, if I were to run a query on business unit view E, it would still have to run this join again, and then run the other query on top of that join. Okay, so then what I might do is decide to do a materialized view in most database systems, and that would create like a physical copy of that result set. There's a couple problems with that though. The system may or may not keep that copy in sync with that original query. 2, it creates another namespace. So now like it's not business unit view E. There's gonna be a separate name like business unit materialized view E, and I need to query that. So I have to rewrite my queries, or else I'm still not going to see any benefit in performance. So it creates like a little extra work for the data engineer who has to make sure that that materialized view is kept in sync and consistent, and the data analyst who has to then rewrite their queries. If I were to turn on what's called a raw reflection on this unit, it would still create like a physical copy, but it's going to be in terms of an Apache Iceberg table. An Apache Iceberg table is not just a physical copy of those results. It's actually all the metadata you get in Iceberg. So that metadata acts as an index that allows you to scan that version of the data much more efficiently. But the data engineer doesn't have to keep it in sync. The Dremio system actually will go in there and periodically update that reflection. And the analyst would just still query business unit view E. They don't have to even know that a reflection was created, and the Dremio system will swap that out to fulfill that query. It's aware of these reflections that are created on the side. And then two, there's a what's called an aggregate reflection, which is more like a cube. So a cube would be like essentially a collection of pre-aggregated statistics. So you're building a BI dashboard. So there's a lot of group bys and maxes and mins and all that fun stuff. So you create a cube that kind of collects a lot of that data and pre-calculates a lot of that data, so that way you can speed up that BI dashboard. But once again, this creates a whole other object that the analyst needs to know to use that object, not the original object. And the data engineer now has to update and find a way to keep that in sync with all the data. Again, Dremio takes care of both of those things. So now when aggregation queries, like if I had a BI dashboard built on business unit view E, it would know the swap out as soon as it's seeing those group by queries, and it sees that, hey, there's a aggregate reflection on this data set. Dremio will just swap that out, and you get that sub-second performance. But this is where the semantic layer piece gets really special, because since Dremio holds your semantic layer coupled with its query engine, it can see that, hey, I can see the relationship between all these different data sets. So I can see that user view I is a child of business unit view E. It has that awareness. And so Dremio can now optimize queries not just on business unit view E, but on user view I. So basically, if a query comes in for user view I, even though I never created a reflection on user view I, it could potentially substitute the reflection I created for business unit view E if it'll make the query faster. Okay, so you get this nice bang for your buck, because not only are you creating this logical layer that helps your end users understand your data better, but it also lets the Dremio query engine understand the relationship between all your data sets better to further optimize your queries and leverage that relational cache that is reflections. So that way you get a bigger bang for your buck for every reflection you create. Allowing for all sorts of really kind of strategic ways of accelerating your model without necessarily having to materialize everything. And that's what makes sort of the application of Dremio semantic layer very special, because since the query engine and the semantic layer are coupled and designed with each other in mind, they're able to leverage each other for optimizations that wouldn't exist had they were created sort of separately. Which is some solutions do, where basically the semantic layer is one thing and then your query engine is another thing, but without that sort of co-awareness, they're not able to do sort of these sort of optimizations and create sort of like this higher intelligence cache. Okay, so that's essentially, so just to recap, again, a semantic layer is just, at the end of the day, a place where we kind of define data sets that fall in line with our business logic, that our metrics and our measures, the things that we measure, we create dashboards off, we create reports off of our prepared data sets. But nowadays, we're starting to see, again, that semantic layer be decoupled from let's say BI tools into sort of its own layer. And there's different options for that. And then hopefully today you see how Dremio's solution is a little bit unique in the world of different semantic layer solutions. And if you actually want to see it at work, it's actually pretty easy. This QR code right here on the left is a exercise where you can just literally spin up Dremio on your laptop, make some iceberg tables, and you can actually play around with reflections and things like that right there from your laptop without any cloud infrastructure, and just kind of see it in action. It's pretty cool. Like, what I like to do is I'll create again, it's your laptop, that'll be your compute, so keep that in mind. But maybe I'll try to get a 2-3 gig data set or a gig data set, again, because it's your laptop. I'll run a query on it without reflections, and then what I'll do is I'll turn on a reflection and then run those same sort of aggregation queries, and just to kind of see the difference. And you can see sort of when you do it without the reflections, you should see it's actually still pretty impressively fast, especially when you're just using your laptop computer. You're like, oh, okay, I didn't realize my laptop could crunch that data that fast. But two, you'll also notice that when you turn on the reflection, the difference that it makes, it'll jump to sub-second, almost regardless of how big the data set is, because of the way sort of it works under the hood, which is really cool. So that's what this QR code does. This just takes you to the Dremio Get Started page. So if anyone's interested in sort of going to the next step, but definitely no harm in just spinning it up on your laptop and actually literally seeing it hands-on. Here's some more exercises. These exercises go a little bit deeper. These actually show you with like a database. So, for example, whether it's Postgres, SQL Server, or Mongo, the exercise starts off with you spinning up that database, Postgres, SQL Server, or Mongo, seeding some data into it, using Dremio to actually ingest that data into your data lake, which you use Minio for, so everything's on your laptop. You ingest that data into your data lake as an iceberg table, and then build a BI dashboard off of it using Apache Superset. So it shows you that whole end-to-end data experience from ingesting from your operational systems all the way to building a dashboard, and shows it to you all from your laptop, and how actually simple it is when you're using a tool like Dremio as your sort of intermediary layer. So those are all there. And again, if you downloaded the slides earlier, those will be accessible there. Um, so we'll open it up to questions. But before I do that, let me just put up the slide with the QR code for the course. So again, we'll be doing that Apache Iceberg 10 session course in the coming weeks. So I'll leave that up there, and I'll take a look, see if there's any questions. So let's open up the chat. Okay. Let's see any questions there.
In the Q&A section.
Oh, in the Q&A section. Let me go
Yep.
there. See if I can find that. Where's that?
Should be in the lower right, the activities, and then should be Q&A.
Q&A. Okay, cool. Okay, perfect. Okay. Reference to the data source to create the semantic layer. Teresa, if you're there, if you want, can you come off a microphone? Come off mute. Just explain me a little bit. Give me a little more detail on that question. I'm not sure if I fully understood the question. Twice. Okay, I'll come back.
I'm making her a contributor right now, so hopefully
perfect.
she can jump on mic.
Cool.
Actually, you answered the question in the next slide. And basically, what I was asking is that you were talking about the semantic layer, and I was trying to understand how it, how are you, you're going to the data source. It's more of a reference to the data source, and then you were talking about building the views, and then it made a lot more sense. So that's why I did the check. I got it. I just didn't wait long enough for you to get there.
Oh no, all good, all perfect. Okay, I'm glad we did answer that. Okay, so instead of connecting to Power BI or Tableau, could I connect a foundation model that could use multiple data models and other database sources using Dremio to aggregate the data? 100%. So let me just elaborate on that for a moment. So Dremio doesn't care where the data goes. So basically, Dremio, think of it as like like I always like to think of it as like a two-way funnel, where basically all the data can go in one end of the funnel, and then it can go everywhere out the other end of the funnel. So basically, it's like this sort of layer that sort of brings everything together, so you can govern it, document it, model it in one place. But then the way you connect to the data could either be JDBC or ODBC. It could be Apache Aeroflight. It could be through the REST API. So you have these multiple ways to connect to it that allow you to really connect anything you want. So you can connect a Python notebook, and I like when I connect through a Python notebook, I usually use Apache Aeroflight because that's going to be like the fastest way to pull the data down. And because Apache Aeroflight, you're not serializing the data into a row-based format in between locations. So then I can just quickly load. I can either work with it as an arrow table, or I could turn it over into polars or pandas data frames, or turn it into any other format that I like because it's Python, and then I can just kind of work with it from there. But you can pull that language into any language. It's just as long as you have libraries to connect to JDBC, ODBC, Apache Aeroflight, or REST API. You can literally pull that data anywhere you want, assuming you have credentials that give you access to the data set in Dremio. So
yeah, I guess well, maybe just to give you a little bit of context. I'm not really a data engineer, so
all good.
so I'm at like so I need the like third grade version of everything you just said to really understand it. But my situation is that I'm consulting with a company. They have a lot of stovepipe applications. They have some of their stuff pushed into the cloud. They're using snowflakes. They created 9 data marts. We have a very good data engineer who understands this stuff. So I think I guess the nature of my question is what I'd like to do is to have a large language model, or a foundation model that I could connect to by whatever means. And it sounds like Dremio might be a good way to do it. And then have the company be able to use that large language model within the level of access that they're given to the various data sources. And then basically it would be a poor man's system integrator. These stovepipe applications aren't talking to each other now. But if we use the large language model and you had like a natural language way, my hope is that people who are, at the user level, who are having to open up 5, 6, 7 different applications to write a report or do something, and they're doing a lot of manual stuff, that they could use, Chat GPT or Claude or something like that, that would be connected, and then they would be able to
Yeah,
go across these applications and in a natural language way, and they could get their reports done or whatever else they would want to do.
yeah,
That's
yeah. No,
my
that's totally. Actually, I do know of one customer who is doing that with Dremio, and they've actually
okay.
spoken about that at our conferences. His name is Mark Sears from Immersk, and what they do is they actually coalesce all their different data sources in Dremio, and then they built an LLM client sort of on top of it that basically will pull the whatever, basically based on the question, the natural language question, will pull the relevant data from the different sources in Dremio, and then prepare an answer. Whether it's like, hey, can you give me like the last quarter sales or give me this particular metric, and
Mm.
basically, you can query the data through natural language that way.
Yeah. Okay. Very good.
Cool, cool. Yeah, yeah. No, that's. I'm starting to see more of that. Like that's starting to become more of a thing where basically, hey, this gives me a way to kind of bring all the data together to feed those systems for like RAG models and stuff. Uh,
Yeah. So that's great. And actually, Joe, if you're on here, I might like to follow up with you on this stuff too. If you have some time, I could schedule with you later.
Yeah, absolutely. I'll send you a link to my calendar.
Great. Thank you. I appreciate it
oh,
very
awesome.
much.
No, I always I'm glad I could be of help. Okay, and then I see one other question. Can you speak to the history of reflections and how you came to that semantic layer approach? Were there other models approaches that were considered? Um, I have a feeling I don't know the specific history of sort of how that evolved over time. From the history that I do know, when Dremio first started, like before it was a you got into the data lakehouse space, and it's been in the data lakehouse space for a good 3-4 years now. Like that we were very early on the like the last few weeks have been really vindicating because like I joined up 2.5 years ago, and at that time like we were the only company saying like you had Databricks saying lakehouse but not saying iceberg. And then you had Snowflake at the time; they weren't saying either. They eventually got to Iceberg, and now they're sort of in the Iceberg Lakehouse space. But but in the beginning, it was just Dremio being like Iceberg. A lot of people saying Lakehouse, a lot of maybe people saying Iceberg, but very few saying sort of like both in sort of one full throated thing. And then over the last couple of weeks, you've seen now a convergence on that story where basically it's like Lakehouse, Iceberg, together. That's the way forward. So it's been pretty exciting to kind of see like, hey, everyone finally joined us. But even before that, so even before Dremio was sort of like the tool, I think it's like in its earliest stages, it was meant to be a way to query, like, because the people who created Dremio, the founders are Tomer Sharon and Jacques Nadeau. They're very well known for contributing to a lot of different open source projects, one of them being Apache Drill, which is like a query engine for being able to run like SQL against like different object stores. Um, so that was like one way people used to use Dremio in its earliest days, where like, hey, you'd connect your MongoDB, you'd connect your Postgres, and you'd be able to run like SQL against both of them. And then it just kind of evolved, and basically it became more and more about the data lake. Basically, as Dremio came up with things like reflections that made querying the data lake pretty much more. Um, Basically, Dremio was able to figure out through the reflections through another technology called the Columnar Cloud Cache, where the individual Dremio nodes. So basically, if you have like 10 computers that are running a Dremio cluster, each of those computers will actually cache, like let's say you have certain Parquet files you access very regularly, it'll cache those on the nodes. So that way you don't need to go ask for them. And that would, one, reduce the cost of doing work from your data lake because you're not sending all those API calls to S3, but two, also speed up. So basically, that, and then plus Dremio was part of the creation of Apache Arrow, which is now all the rage in like all data systems to run very fast data processing. So very early on, like Dremio had really, really, really fast performance, particularly with the data lake, because I mean, database systems and data warehouse systems that are very integrated can achieve really good performance, but it was something else to achieve that kind of performance when things aren't integrated with each other, like a data lake, which that storage layer is completely separate from like Dremio. So that became sort of like, so once they kind of hit that sweet spot and find, hey, we kind of figured out like the fastest way to query data lakes, that became more and more sort of like Dremio's business. So we connect to lots of sources, and we're still pretty fast on all those sources. So I would say faster than any other similar solution. And we connect to on-prem sources, which is another nice side benefit. But basically, that as we got into that space, which was and we started sort of fleshing out things like reflections and columnar cloud cache, that became sort of more and more core to what we do, and really sort of making a data lake very, very operational, something that you could easily use that doesn't turn naturally into a data swamp. And then basically with things like Apache Iceberg, as those kind of arose, it made it really clear that now that data lake could not just be something that's more operationally used, but something that could actually turn into your data warehouse, and thus the sort of the screaming at the rooftops of data lake houses are cool, because basically it does become pretty easy. Like if you do some of the exercises I shared earlier, it's pretty. I mean, I remember, like it doesn't feel like you're not using a data warehouse. It feels like you're using just your normal data warehouse or database system, but you're really using a completely decoupled query engine and storage layer, and you're getting really good performance with a really easy user interface that makes it really easy to use. And oftentimes that's sort of what Dremio brings to the table, and sort of where our sweet spot is, and making it where all your data feels like it's one system, so that way your users can focus on just getting the data they need, instead of thinking, hey, what are the 20 different places? Do I have access to those 20 different places? And all that kind of stuff. Or vice versa, a data engineer having to spend all day moving all the data to one place from those 19 other places to make it easier for the end user. It's like it's always one or the other. Either it's really hard for the end user because the data is in too many places, or it's really hard for the data engineer because they're moving all that data from 20 different places into one. This kind of solves both problems. So I that doesn't address specifically the question of which is like sort of the evolution of the semantic layer at a technological level. Now I'm going to go back to the engineers and talk some of the ones who've been around longer, and see if they can give me any insight on that. Because now I'm curious. Like, okay, hey, what order did the features get released? Because like the semantic layer and reflections, those are features that pre-existed me being around. So I'm kind of like, I know a little bit of the history of the revolution, but I know more about the recent innovations in both of those features. So hopefully that.
Very, very cool.
Yeah, no, it's a very cool technology, and the more I dig into it, the more excited I get about it, which is why I talk so much.
Well, and that's the thing too, is like, it's a great question. And like there in the literature, if you go to archive.org, you're digging around, Google Scholar, Semantic Scholar, there are so many strange lineages of how semantic layers evolved and semantic approaches evolved. And it doesn't seem like any one person does it the same as the other group or the other lineage of evolution for a certain semantic solution. So it's always interesting to hear how certain platforms or certain SaaS or certain solutions writ large get implemented, and how those semantic layers are complementary to the expected outcomes of those solutions. So it's just very interesting history lesson in terms of how those kind of integrations and applications get developed and deployed.
100%. Yeah, it is semantic layer is definitely one of the specific fields where I feel like if I ask 10 different people what is a semantic layer and what a semantic layer product should look like, you get 10 different answers. Versus like a lot of other things which are a little bit more kind of more fine grained. Like if I ask people, how do you normalize data, that you'll probably get a more consistent answer on, versus like, okay, how do you develop a semantic layer? I'll get much more variety. So yeah, but oh, go for it.
I said absolutely.
Yes. But yeah, if I don't see any other questions. So again, as usual, always thank you, Joe, for having me. As always, and I'll be back again hopefully soon in either next month or early August. But either way, scan that QR code. If you don't already follow me on LinkedIn and Twitter, do follow me on LinkedIn and Twitter. Again, I appreciate all of you guys sticking around with me today on Thursday. I know there's other very exciting things happening this afternoon that people might be more entertained by, but I'm glad you guys chose to spend an hour with me.
Yep. And for everybody else's information, the recording of this will be put on YouTube later through, I believe, Dremio's YouTube channel. If you would like to contact or follow Alex and what he's up to, his contact information and social media is in the description for the event. If you would like to reach out to the broader Tampa Bay Data Engineering group, we do have a Slack channel inside the Tampa Devs, and that information is in the About section for the Tampa Bay Data Engineering group. And if you'd like to contact me, message me through Meetup or through the Tampa Devs Slack. Any parting shots, Alex?
No, basically, again, thank you all very much. Far as the easiest way to find more information to follow up, right here, the website bio.alexmerced.com/data has links to all the different social places that I'm at, the podcasts, everything you need to kind of learn more. So yeah, again, thank you so much.